I'm trying not to start each of these with okay. I find that all these videos start with okay. We're doing 1.5, so I'm trying hard not to do that. We are starting 1.5. I left the word okay out. So, applications with logarithms. So, I felt like last year it was sort of bad that we covered logarithms, and so I added something about some applications so it's not just a pure topic. Things that use logarithms. The Richter scale. When you hear an earthquake. When you hear something was a 7.1 earthquake, we have taken the log of some measurement and we came up with 7.1. That's what it means to have an earthquake. It's using logarithms. Same thing with pH in chemistry. You may have studied something has a pH of 3.1. I took the log of a number to get that, okay? So when you have really big numbers or really small numbers, a logarithm can get you down to a number that's you can count with your hand, you know, like a 3 or a 4 or 5 or 6 or 7. So that's why we use log scales, because it can make the numbers much more manageable. Sound levels in decibels. You know, when an airplane goes off, we say that it measures like 110 decibels. Okay, we've taken the log of something much larger than that to get that number. So these are just a few examples of measurements that we use on logarithmic scales. Now, we are only going to do one example of that in this class today. We're going to talk about earthquakes. Every problem that I work today with an earthquake is going to be just like the problem you'll see on the quiz. Okay, so I want to give you two earthquakes, and you tell me which one is stronger and how much stronger the earthquake is. Okay, that's all we'll be doing in the earthquake problems. So let's look at this example. We have a formula, and I will give you this formula on the test, but you have to know how to use it. M is equal to log base 10 of I, where M is the magnitude of the earthquake and I is its intensity. That's the amplitude of the vibrations or the shifting of the earth. So what we're going to do is compare two earthquakes. So your problem is going to look much like this. The Loma Prieta earthquake in San Francisco. You guys don't remember that. It happened during the World Series in San Francisco. It was 6.9 on the Richter scale. Okay. The worst earthquake we've ever had in San Francisco was in 1906, and it was 7.8 on the Richter scale. Which of those earthquakes you think was worse? The 7.8. Okay, the higher the number, the worse the earthquake. So I want to figure out how much stronger was the 7.8 earthquake than the 6.9 earthquake. Okay, the way we do this, first find the difference. So 7.8 minus 6.9. Okay, I'll subtract that and I get what? 9, is it 0.9 is the answer? So that is the difference. And now I'm going to use this equation, M equal the log base 10 of I, and this number that I have right here, that's going to be substituted in for the magnitude. So I've got 0.9 equal the log base 10 of I. This is a log equation. I have logs on how many sides of this equation? One side. What's my strategy for solving a log equation that has a log on one side? Convert it to what? Exponential. Okay, let's look at this. What is the base? Base is 10. Okay, what is the exponent? 0.9. So 10 to the 0.9 equals what? I. So that tells me how much more intense the 7.8 earthquake was over the 6.9. So 10 to the 0.9. Does anybody know what that is? Okay, you got to figure that one out. So I'm going to figure out then 10 to the 0.9 power. This is where you will use your TI Inspire. So 10 to the 0.9 power. And will it estimate that for me? 7.94328. Okay, so all I did was the number 10 and then this caret sign raised to the 0.9 power 7.94328. So I equals 7.9, what did I say? 94328. 0.4328. This is a word problem. The answer to a word problem always has units. It also has, it's a word problem. The answer to a word problem has words. There we go. Okay. So the 1906 earthquake was 7.94328 times stronger than the 1989 earthquake. Okay. You don't work a problem like this and just write 7.94 is the answer. And it's okay if you round it, 7.94, 7.943. The answer is not 7.94. The answer is the 1906 earthquake, or the 7.8 earthquake was 7.94 times stronger than the 6.9. Okay, pretty straightforward. Okay, they're all going to work like this. There are no ways of me tricking you on a problem like this. Let's do another example. How much stronger is a 7.5 earthquake over a 7.2? Okay, what's the first thing I need to do? Yeah, find the difference. So 7.5 minus 7.2 is what? 0.3. I mean, that doesn't feel like much difference. Okay, the earthquakes were 0.3 apart on the Richter scale, but that's a logarithm scale, and these are exponents. So it's going to be a bigger difference than you realize. Okay, our formula is m equal the log base 10 of I. What do I substitute for m? The 0.3. Okay, so this number, that is my m. So 0.3 equal the log base 10 of I. That is a logarithm equation that I solved by converting to what? Exponential form. What's the base? 10. What's the exponent? Yeah, so 10 to the 0.3 equals I. How do I find out what 10 to the 0.3 is? That's where I trust my calculator. 10 raised to the 0.3, 1.995. Okay, so this is 1.995 equal I. So to answer the question, the 7.5 is 1.995 times stronger. Okay. So basically, a 7.5 earthquake is about twice as strong as a 7.2. Okay. So in your mind, when you think like, oh, there was a 7.2 and a 7.5, they sound very similar, right? Okay. They don't sound like that far apart. If you made a 7.2 on a test and then somebody else made a 7.5, not much difference, right? But on a logarithm scale, that difference is much stronger. So this earthquake is about twice as strong as this one, okay? So I picked this application because this is probably where logarithms most occur in your life. Hopefully you're not in earthquakes, but you hear about them. So when you hear these numbers, know that that's a logarithm scale that's going on. And there we go. One more example of this, and I think we're pretty good. So you'll see one of these problems. It's going to look pretty much like this on the test, okay? Again, I'll give you the formula. I'll give you two earthquakes, and you tell me how much stronger one is than the other. The 2011 earthquake in Japan measured 9.1 on the Richter scale. That's pretty strong. How much stronger was that over the 1989 San Francisco earthquake of 6.9? What do I do? Yeah, so 9.1 minus 6.9, just so I don't make mistakes with my arithmetic. 9.1 minus 6.9 is 2.2. Okay, my formula is m equal the log base 10 of I. What do I do with the 2.2? That's m. So 2.2 equal the log base 10 of I. Now we convert this to what? Exponential. So what's the exponential equation? Yeah, 10 to the 2.2 equals I. I go back to my calculator. 10 raised to the 2.2 is 158. We'll call it 158.49. So I equal 158.49. Is that my answer? Yes or no? No, my answer is the 9.1 is 158.49 times stronger than a 6.9. That's a huge difference, okay? Anytime you hear an earthquake that's like upwards of 9 or 10 or something like that, that's catastrophic. So it's about 160 times stronger than the worst one we've had in San Francisco in the last, 40 years, okay? So this is the one that caused the big tsunami in 2011, okay? Okay, so that's an application of logarithms. Last semester we did a few others, but that's the only one I want to cover here, okay? And like I said, just so that you know a use of logarithms, that's the way the problems work. There'll be some in your homework. There'll be one on the assessment, the quiz, that looks just like that. Now, another skill that we need to have in our back pocket before we get to the next unit is how to solve for an exponent using logarithms, okay? So this is a problem that we did last semester. 2 to the x equal 4. Now that's pretty easy. What is x? X is 2. Okay, you know that 2 squared is 4. The other way of writing this is 2 to the x equal, I can write 4 as 2 squared. If 2 to the x equal 2 squared, then x has to be what? It has to be 2. Okay, that was easy to solve because I can write 4 and 2. They're both powers of 2. Okay, that's pretty easy to do. How do I solve 2 to the x equal 5.4? Can I write 5.4 as a power of 2? No, I can't do that. So I can't solve this just like I did all my equations last semester. But now that you know logarithms, you have a way of solving it. So let's take a look. I want to solve 2 to the x equal 5.4. What I'm going to do is I'm going to take the log base 2 of both sides. So let's do that. On the left side, I will have the log base 2 of 2 to the x, and on the right side, I will have log base 2 of 5.4. Now, someone look at the left side and tell me, why did I take the log base 2 of 2 to the x? What does the left side simplify to? It's what? Not 2. Not 2x. We've talked about this several times. You need to be able to look at that and tell me what that is without doing much work. It's x, okay? 2 to the x and log base 2 are inverse functions. So log base 2 of 2 to the, I said the G-rated version was whatever the heck, whatever's up there. This is log base 2 of 2 to, I don't care what this is. That's your answer, okay? You've got 2 to the x, log base 2, these are inverse functions. What this gives me is x equal the log base 2 of 5.4. That's how I solve for x. Does anybody know off the top of their head what the log base 2 of 5.4 is? How do you think we'll figure that out? That's where we use our calculator. So that is my exact answer. X equal the log base 2 of 5.4. When I was working the review, I'm okay if you get there. That's the exact answer, but I want you to also have the skill of doing this on your calculator. Log base 2 of 5.4. Your log key is this blue button right here, so control, I see log, okay, I see a subscript in here. So what goes here? 2? okay? And then what goes here? 5.4, and I get an answer there, 2.433, okay? 2.433. Now, if you've got, your calculator did not do it. This one, you got to have the TI. This only does log base 10 and natural log. So you have to have the TI Inspire for this, because it allows you to do other bases. So 2.433. So X is 2.433. Okay, that's my approximation. We're going to need this skill after the assessment when we start doing exponential modeling. So I want to cover it now so that you know how to do it. So the basic premise is when you've got an exponential equation like this, look at your base, and you want to take the log of that on both sides. That allows you to solve for the exponent. So let's look at the next one. E to the 1 plus x equal 25. I'm going to take the log, which base on both sides? Log base what? Not 10. E, okay? I've got e to the 1 plus x. I need to take the log base e. Another word for log base e is what? Natural log. So I'm going to take the natural log of both sides. So this is the natural log of e to the x plus 1 equal the natural log of 25. Take the natural log of both sides. What is another way of writing ln? It's what? Log base what? Natural log is log base what? E. Log base e of e to the x plus 1 equal log base e of 25. Please tell me you know what the log base e of e to the x plus 1 is. It's x plus 1. Yes, Maddie?
So on the assessment, if we were to write like what you were on the bottom one on the top, it would be wrong.
Both of these are correct. I don't care which one you do. Sometimes this one, you have to know in your head that's log base e. If you struggle with knowing that's log base e, just write log base e. I don't care. Okay, either one of those is fine. But the reason I write it like this is you should be able to look at it and say the log base e of e to the x plus 1 is, repeat it again, x plus 1. That's why I took the log base e. It allows me to solve for the exponent. So x plus 1 equals the log base e of 25. How do I solve for x in that equation? How do I get the x by itself? Subtract 1. So x is negative 1 plus natural log of 25. This is my exact answer, okay? So you need to be able to work down to that, and then you need to be able to use your calculator to give me an approximation of that. That's my exact answer. To get an approximation, I'll go to my calculator, and I'm going to say negative 1 plus, and you can do it two ways. You can do, well, the easiest way to do it is just use the ln key. So to the left of the log, so it's control natural log of 25. And let me back up. I want to get my approximation there. Control enter, and I get 2.219. So this answer is x equal 2.219. So like here, yeah, I want you to come up with x equals something. Okay, so it's x. This is your exact answer. I want you to get to here, and then I want you to be able to use your calculator to give me an approximation of that. So on the way the quiz works is I'm going to say, give me the exact answer. Now use your TI to approximate that for me. Okay, that's the skill. The approximation, we'll be needing that a lot when we get in the next unit. Okay, so the skill here is whenever you see an exponential, look at what the base is, and you need to take the logarithm of that base. Okay, It wouldn't make sense if I took the log base 10. Let's just say, for example, if I did the log base 10 of e to the x plus 1. I don't know what that is, okay? That is not x plus 1, okay? The only log it's only the log base e of e to the x plus 1. That's the one, this is x plus 1, okay? This is not x plus 1. So you have to take the log of the appropriate base of both sides. Now this is where your TI is pretty handy. Most calculators 20, 30 years ago didn't have this, and you had to convert bases, okay? We're not going to go there. So your TI is pretty cool that it can take any base that you throw at it. Let's look at the next one here. 35 times 0.5 to the x over 4.5 equal 10. Now what I want on the left side, I want the exponential all by itself, okay? What's being raised to a power? 0.5. The 35 is there just to mess you up, okay? How can I get rid of that 35? Divide both sides by 35. So I'm going to write this as 35.5 to the x over 4.5. I'm going to divide both sides by 35. What happens on the left? What do I get? Yeah, I get 0.5 raised to the x over 4.5 equal, and I just get 10 over 35 on the right. Okay, now do I have an exponential equation, something isolated raised to a power? Answer would be what? Yes. What logarithm, what base will I be taking on both sides? The log base 0.5. So I need to take the log base 0.5 of 0.5 to the x over 4.5. That's going to be the log base 0.5 of 10 over 35. Now that looks really complicated, but look at the left side. What is the log base 0.5 of 0.5 to the x over 4.5? Right, you're getting this. This is just x over 4.5 equal the log base 0.5 of 10 over 35. How can I get that x by itself? Yeah, multiply both sides by 4.5. And I'm going to get my exact answer is going to be, I'll write it here, x equal 4.5, the log base 0.5 of 10 over 35. That's my exact answer, okay? This is probably as ugly as these get, okay? That's my exact answer. We follow the same process of what we've been doing. How do I get my approximation? Yeah, use the calculator. So I need to find out what is 4.5 times. The log key is this control log. Log base what? 0.5 of what? 10 divided by 35 and 8.1331. So that is my answer. So x is 8.331. That's my approximate answer. Okay? That's it for today. Okay? So what you need to do, if I give you a scenario that compares two earthquakes, okay, you can find the difference, set up the equation, use your calculator, and then give me words back that answer that problem. The other thing, if I give you any exponential equation, you can isolate the exponential term, look at whatever that base is, and take the log of that base on both sides and understand how that makes one side of the equation simplify down to just your exponent. That's the whole point of taking a logarithm, is you're solving for the exponent. Okay? Any questions over that then? Okay, so I will not see you tomorrow, which is Wednesday. I see you on Thursday, which is our block review day. So, is it late start? No, no, no. No, Friday's late start. So we start normal time. So block review early on Thursday. So there is a review on Haiku.